Hi guys, I'd like to welcome all of us to my channel of Honesty Sciences and Mathematics TV channel. Today we're going to look at the concept of dilation, and this will form our last bit of the concept of transformations in summary form of these four specific areas that we have looked at. So in our previous videos we had looked at the concept of reflection, translation, and of course rotation, and we have mentioned various characteristics of these particular types of course transformations which are going to be perhaps safely applied in subsequent videos on various topics in geometry. Now, the concept of a dilation basically we said that to do a dilation is basically to enlarge or reduce an object. So basically we can be able to define just generally a concept of a dilation as to enlarge or reduce an object. And of course, this is just similar to making an object either smaller or large. So this is associated with the concept of dilation. We're going to see the aspect of magnitude being employed, whereby this is going to be in terms of quantity. So therefore, in case we use numerical figures in trying to describe this particular aspect of dilation, then therefore that's going to imply the concept of magnitude. So therefore, we can be able to do a dilation of a magnitude of an object, perhaps times 2, then therefore this is going to imply that we're going to enlarge that object by this specific factor. So in case we perform a magnitude of times a half, then therefore this is going to imply reducing that object by half its size. So this is going to be more elaborate if we're going to perform an illustration, and perhaps try to see how that one can be performed. Now suppose I have a triangle, and this is going to be a triangle. So let me have just an illustration of a triangle given as such, and this triangle ABC given as such. Now if I'm told to perform a dilation of magnitude 3 centered at a particular point, let's just refer to that point as P. So this is a point P, and then I'm requested to perform a dilation of magnitude 3. So which means the image that I'm going to obtain from this specific process of dilation is going to be an object which is 3 times larger than the object, or an image that is 3 times larger than the object. So for me to perform this one, I'm going to make a line from the point P to this particular point A, which is going to be I'm going to draw a straight line from this particular point P, which is a point of course, a central point, which we are referred to as that is a center point P. Then therefore I'm going to consider the distance between P, A, and I'm going to make this one, the point from P, 3 times larger. So which means I'm going to extend this line to be twice as big as AB. Then therefore the magnitude from point B to another point A prime is going to be 3 times this specific distance for AB. So therefore I'm going to consider this one as the first portion, second, and third. So which means from this center point A, I've been able to translate A prime by a factor of 3. So next then, I'm going to consider the case of a point, so let me just make them those dotted so that we cannot congest our image and object. So I'm going to have the second line drawn from that center point, and then consider 3 times the distance between this one and that one. And therefore the distance between PC, so from the point P to C, I'm going to draw 2 times that particular distance, perhaps the first one at that point and the last one. And this is going to mark C prime given as such. So that is going to be my point for C prime given as such. And lastly, I'm going to perform another translation. I hope this distance is going to be, and this is going to be 3 times the distance between BP. So therefore we presume the first one ends there, and I'm going to have this B prime at this specific point. So therefore for me to obtain the image of this specific process of dilation, I'm going to join these vertices for A, C, B, to obtain that specific image. So this is going to constitute ABC is going to constitute my object, and of course A prime, B prime, C prime is going to constitute my image given as such. So the process of transforming A, B, C from this specific point using this center point to A prime, B prime, I prime is referred to as the process of dilation. So of course, we're going to see that in trying to perform the concept of dilation, there are some various aspects which are going to be preserved, particularly the concept of angle measurement and orientation. As we can see, by trying to travel in the around this triangle in anti-clockwise direction from A, B, C, and this is going to be the same orientation that I'm going to assume in traveling from A prime, B prime to C prime respectively. So therefore, the concept of orientation is going to be preserved, and the angular measurement, if this one is 60 degrees, that is going to be 60. If this is perhaps 60 or 65, that is going to be the same, and this is going to be, if it's 40, and this is going to be the same. So concerning this specific orientation, then therefore in dilation, there's going to be preservation of angular measurement and of course the orientation of the object. But we're going to see that one thing is going to be changing, of course, that is going to be the distance or the location of that specific image from the object. So therefore, that's how we can be able to just have an overview of the concept of dilation. And later on, as we are going to use graphical representation, then therefore we can be more elaborate on various vertices which we are going to obtain. Of course, considering this one maybe in a Cartesian coordinate system and other aspects. So that is it for now, guys. I hope that this concept of a translation for the four aspects of reflection, rotation, dilation, and a translation is going to be more elaborate for us as we're going to look at the various other videos. So kindly consider checking our description boxes for various links of other videos which are going to assist us understand deeper this aspect of transformation. So that is it for now, guys. Bye, God bless you. Catch us in our next video.